I work for Hyperscalers as a cloud architect, and at Hyperscalers we help customers design and perform proof of concept on various cloud solutions, which would include hardware and software architecture design and performing the benchmark assessment on the complete appliance. So the objective of this proof of concept is to do Red Hat Enterprise Virtualization appliance on Quanta computer servers. At Hyperscalers, we run a cloud-enabled lab where we do the proof of concept on these software vendors. So as part of this proof of concept, we are doing Red Hat Enterprise Virtualization and SAP HANA on top of it. And we are going to run the benchmark performance numbers on the virtualization software and some database benchmarking on SAP HANA platform. So we'll walk through this document, and I will demo these appliances one by one. So to begin with, let's look at the architecture what we are following. So this table shows the hardware boxes and software installations we are using in this POC. Broadly, we are using two server nodes, the Quantaplex T42S. It is a 4-node server, out of which we are using 2 node, and both of them are pretty are bundled with pretty high-end CPUs and RAM. We have Skylake Gold 6130 CPUs and about 160 gig RAM on each node. So 16 GB RAM and 10 populated on per node. We are using the SATA SSDs of 240 gig space for OS installations, and for storage we are using about 2 terabyte SGST SAS SSDs. So these SSDs are pretty fast performing hardware, and we have done a lot of other appliances on these storage boxes as well. For networking, we are using Cumulus Linux, the bare metal switches coming from Quanta Mesh in leaf and spine architecture. I will log into these switches as well and show how these configurations are done. From the software side, we are using Red Hat Virtualization 4.2. Working with Red Hat, we got the license, and we have gone through the steps of installing this on these hardware. For SAP HANA evaluation, we are using SAP HANA, or rather SAP HANA Express 2. This is a evaluation software or installable being given by SAP HANA for developers and architects to play around on the appliances and benchmark the performances. So we are using version 2 of it. The Cumulus Linux Open Networking OS is version 3. We have these switches up and running in the Hyperscalers lab, and we play with the capabilities of Cumulus, VXLAN, and other SDN capabilities. The VirtualBox is the hypervisor we are using to get SAP HANA up and running on Red Hat Enterprise Linux OS, and we'll walk through this demonstration as we go through. Okay, so this is the architecture, broadly the hardware or system architecture we are following. The 2 nodes, the Red Hat virtualization requires minimum 2 nodes for its to be installed or to get it completely functional. So we are using 2 of them. One is being treated as manager node, and another is the host node. The manager node is where the manager IDE of Red Hat Virtualization is installed, and once it is installed, the data path is configured as 25 gig coming out of manager node, and it is connected to connected to Cumulus leaf switch, which uplinks to 40 gig spine switch, which supports up to 100 gig spine. But in our lab environment, we are degrading it to 40 gig uplink. So effectively, manager node traffic coming out is 25 gig and uplink is 40 gig for the network backbone. On the host side, the network architecture is same. The data path going out is 25 gig, and the leaf and spine architecture converts it to the uplink. On the host node, we have dedicated few SAS SSDs for storage domain purposes, and that is being connected through Fibre channel protocol to the manager node. I will demonstrate all these interfaces, and those disks are presented to the manager IDE, the Red Hat Virtualization Manager IDE, as storage domain, and every virtual machine created on the manager side utilizes those disks as a storage space, and we execute the performance benchmark on those virtual machines, which in turn utilizes these storage drives, and we capture those performance numbers. The other aspect is the management path of all for both manager and host node are through 1 gig BMC, which is not shown in this diagram, but typically all BMC IPMI interface goes through 1 gig, so that is how we control these nodes. And yeah, so let's look at these nodes one by one. To begin with, this I will walk through all these screens, so bear with me if it is not very consistent. So these are the leaf and spine switches. The left hand one is this one is the spine switch, the 18.142 IP. You can see there are multiple bridges, and there are 100 gig ports, and it is auto negotiated as 40 gig for enabling the traffic to go uplink. And so this spine takes the traffic towards router, which is kept on top of rack leaf switch. So this is the top of rack leaf switch. You can see there are a couple of ports here, 5 and 6. That is where the host nodes are connected, and there is a bridge which converts 10 gig to 40 gig and sort of uplinks the traffic to the spine switch. And so this is the top of rack and spine switch architecture, and this is running Cumulus Linux on it. So this is how in Hyperscalers lab we typically design all our appliances through leaf spine architecture, being enabled through Cumulus Linux. So this is as far as network switches. These top two boxes are concerned. These are two host nodes and management node. This is the BMC KVM for both of those nodes. Both of them are running Red Hat Linux 7.3, and that is the base operating system being used for the complete installation. I will just log in to show. And this is where the complete host and all the installations are done. We'll come back to this window as we walk through these steps. So this is basically the architecture. I showed you the manager node, host node, the BMC and KVM for these nodes, and the Cumulus Linux enabled switches. So this is the architecture on which the whole appliance, the Red Hat Virtualization, SAP software are running. So let's go to the Red Hat Virtualization window. So we followed the steps provided by Red Hat to get the complete installation done on the Red Hat Enterprise Linux 7.3. We enabled the license. We went through the installation process. There are multiple steps involved there. The Red Hat documentations have all those steps. So this is the Red Hat Virtualization Dashboard, which is running on manager node on this node, and uh, using this interface we can tie up the host node as well as the storage running on the host node. We can configure the network internally to the management node, which ties up the virtual machine so that any virtual machine running on the management node can communicate to each other. As well as there is a protocol called there is a rather plugin called Cockpit plugin, which is installed on the host node. So when we install Red Hat Enterprise Linux on host, we need to install the Cockpit plugin as well. That would enable the host to be visible to the manager node, and that's how they can communicate to each other. So after installation, we get this management window. The first thing we needed to do was to add a host. So this host is this box, the host node, and we configured the IP address. The cockpit plugin being installed on host enabled the management window to communicate, and sort of the status should be up for the host node to get the complete cluster up and running. And once it is up, the compute capabilities or the compute resources of the host node are visible to the management interface, which can be utilized to create virtual machines. And the resources, the CPU memory storage, not storage, the CPU memory resources coming out of the host node are used for the virtual machine configurations. So you can see here, first we need to add a host, which is this box. And then once we have the host up and running, we can create a cluster which would involve multiple hosts. So one of the hosts is up and running here, although there is one more host which is there is one more cluster which is just a template. There is no host attached to it. And once we create these clusters, all of this can be tied together in as a data center. So you can see here there is one data center which is up, and this data center consists of one domain, one cluster, and it has multiple hosts and all the details. So all these configurations can be done using this dashboard. That is as far as creating the data center architecture is concerned. Once it is done, we need to create the storage domain. Storage domain is where the storage would be available. And so when we create the virtual machines, we need to provide the storage part of it. So to do that, we first need to create a storage domain, and this is how to do. If we go to storage, there is domain, and we can add new domain. And so in this situation, in our installation, we are using the Fibre channel protocol storage pool, and we have dedicated few drives on the host node which can be used as storage for this the virtualization management window. And we have enabled this is how to do. We can select what type of protocol we require. I selected Fibre channel, and once I selected Fibre channel, it will show the host which is already attached to the system, and it will show the available LUNs on the host system which can be used. So in our case, we had one about 2 terabyte SGST drive, which I had dedicated for the storage purpose. I have selected it, and that enabled me to add as a storage domain to this system. And once we do that, we can go and create virtual machines. So for example, if there are 3 virtual machines running here, and 2 of them are running CentOS Linux, and one of them is Windows. So if we do a new virtual machine, it will ask for all these details. We can fill them in, and when we have to for example, when we have to create the hard disk, we'll have to select we can we can select the templates, and we can sort of assign the resources here, and we can attach the NIC. I mean, for this example, as while the time of installation, it asked me to create an internal network, and I created this, which is a management network running within the within the Red Hat virtualization window. And it can be used, or we can create new NICs as well for situations based on the way you want to configure your virtual machine. Another thing to add here is once we, rather I'll take you to the host, to one of the hosts. This is the KVM of one of the hosts, and from here you can see this is the same dashboard, the management dashboard, and whenever I have to upload some data, like for installing the virtual machines, I needed to upload the ISO image. So this is the management window in which we have all the DNS configurations done. I mean, you cannot attach the ISO or any data disk drive to the management window unless your DNS configurations are done correctly. So in this situation, in our appliance, the DNS configuration is done on the management host itself. So if I open the window, the Red Hat Virtualization Management window, and if I do upload start, it will give me a window where I can from where I can upload any ISO image or any data disk drive to make sure that we have all the DNS up and running, configured correctly. We can test connection, and it should show that yes, connection is good. And if we do that, it would give me a window where I can select any image which needs to be uploaded, and I can upload. So in our appliance, I have uploaded CentOS and Windows ISO images and created 3 virtual machines for this as far as this appliance is concerned. So I will quickly show you these virtual machines. For example, I am let's start with this Windows virtual machine. So Red Hat Virtualization provides multiple ways of showing up the console. Like in our case, in this case, I am using the VNC, Open VNC protocol to open the console, and it gives me a console in this way. Since I have enabled the VNC, it gives me the remote viewer for the Windows Virtual Machine console, and you can see here that the virtual machine is up and running here. And in this Windows Virtual Machine, I am running IOmeter. So IOmeter is a storage performance evaluation utility. You can see that you can keep it running for some specified time on a specified drive. I have selected C drive on this, and the disk drive which was on the host is configured as fiber channel storage to this virtual machine, and I can see that it gives me some storage performance numbers. So this typically any appliance we do in Hyperscalers lab, we run this tool to see what performance numbers is it giving. So in this case, I am getting about 150 megabytes per second, which is not the best number I was expecting, but if I configure the virtual machine correctly, networking and storage side, the performance should go better. Another performance number I wanted to show are on these 2 CentOS virtual machines. So these are those, not this. So these are 2 virtual machines. So this is virtual machine number 1, and this is number 2. Both of them are running CentOS. So I am running a Hyperscalers in-house utility called Virtual Machine Performance Measurement Utility. So what this dashboard is showing that we are running our virtual machine, which is sort of giving the performance number of itself to this virtual machine. This virtual machine is treated as a server, and the another virtual machine is the client. And you can have multiple client, and all of them would execute their performance plugin and push the data to the server. And this table would grow as and when multiple virtual machines are executed, and they send the performance numbers to the server virtual machine. So you can see here the network performance is coming some around 480 megabits per second, which is pretty good, because in our lab, for a Linux systems running on same subnet gives something around 110 120 megabits per second. Now in this case, since we have for 25 gig and 40 gig uplinks going out, it is the network performance is pretty good. This is compared to other appliances which are running on 10 gig backbone. This number is pretty good since it is running on 40 gig and 25 gig backbones. On the disk speed side, this 330 megabytes per second is the read-write performance on the disk on the client CentOS virtual machine, and this is pretty good compared to since it is the virtual machines are just have 4 gigabyte of RAM, and as we bump up those memory on each virtual machine, this performance is expected to go up. In couple of instances, I have seen this number to go something around 1 gigabyte per second. So based on the way we configure the virtual machine and based on the way we run the operating system, we configure the operating system, the performance of this speed really goes up. So this is pretty good. Typically the number which was 110 megabytes per second has gone up to 330, and with much better tuning and virtual machine configurations, this would go something around 1 gigabyte per second. So till now what we have seen is the Red Hat Virtualization Manager running on the manager node. It is being able to access the storage and the host node through this Fibre channel protocol and the cockpit plugins. And we are able to execute virtual machines on top of this management node. And those virtual machines are able to utilize the storage drives, and we are able to execute the performance stress test on those virtual machines. So till now we have shown those numbers, and as well as we have shown the Cumulus Linux switches and the way those configurations are done. Now let's move on to the SAP HANA installation. So if I move, so this document typically talks about the architecture and some of the scripts we have been executing. It talks about the manager, web IDE, and what all configurations. There are some screenshots of the virtual machines and stuff like that. It shows the disk and network performance as well. Let's jump into the SAP HANA Express installation. On Red Hat Enterprise Linux, there are multiple ways of evaluating SAP HANA. The first one is to get Red Hat Enterprise Linux SAP enabled operating system, and SAP HANA provides SAP HANA Express version, which is an evaluation installable being provided by them, and we can install it on Red Hat Enterprise Linux SAP HANA version and perform the performance benchmarking. That work is still in progress. There are some specific configurations required on SAP HANA enabled RHEL, and probably as next step of this appliance we do that. Another way is utilizing Ansible Tower of coming from Red Hat, and that Ansible Tower is Red Hat Cloud to which we can create a login, and it would give a pre-built SAP HANA enabled Red Hat Enterprise Linux virtual machine, and then we can put the SAP HANA Express onto that and run it as an appliance. Uh, that work is also in progress. That would require some configurations from Hyperscalers and from from Red Hat side to get that appliance up and running. So that is also a work in progress. As far as this appliance is concerned, what we have done is SAP HANA Express installable supports VirtualBox. VirtualBox is an Oracle provided hypervisor on which you can create virtual machines. So what I did here is on the management node, I will log back to the management node, and on this management node I have created which is already running Red Hat Enterprise Linux, which is subscribed to the Red Hat virtualization licenses. So it supports VirtualBox as a hypervisor, and we have loaded the SAP HANA pre-built virtual machine, which is platform independent, and it can be executed or it is being supported on Oracle VM, Oracle VirtualBox, and that VirtualBox is running on Red Hat Enterprise Linux operating system. What we as well tried is to customize the SAP HANA OVA file, which is the pre-built virtual machine file, and tried loading it on the Red Hat virtualization platform. That has some compatibility issues which I am still debugging. But what I am able to achieve is this VirtualBox on Red Hat Linux platform is executing, and I am able to get the SAP HANA service engine up and running. So once that install, again, it involves multiple steps as suggested by SAP HANA. We went through all of that, and I'm able to get SAP HANA virtual machine up and running on Red Hat Linux, and it gives me an engine which is running SAP HANA, and we can see the multiple appliances. If this is the list of appliances which are running on this engine, and it gives an interface to all these engines. So for example, the web IDE is the interface where all the databases and other apps related to SAP HANA can be loaded. So we executed it, and it gave me a link to execute the web IDE. So I'll show that web IDE here. This is the link, and to get it up and running, there is a management IP of the SAP HANA engine, and that management IP is being updated as a host link, like this HXC host is the typical host name being used by SAP HANA engine, and I have redirected this name to the engine IP address. So so that any apps running on SAP HANA is hidden behind this name. So once we get this engine up and running, once we get the SAP HANA engine up and running, all these links would be enabled, and we will be able to log into the dashboard. For example, in this case, this is the dashboard we got, and it gives me multiple prompts, and there are multiple steps. We can create new project. There are some limitations with SAP HANA Express, since it is an evaluation ISO. It doesn't give all the features, but there are some basic features which we can utilize to execute our performance numbers. So going back to the SAP website, it has a lot of modules or database exercises which we can do. In this case, I have done a SDI module, which is a HANA database module, and it loads a module, and you can create multiple fields using these scripts. And once you load these scripts and you execute, there is a run option. When you run that complete database, it will create the database in SAP HANA engine, and that you can load. And effectively, once it is loaded, you will be able to sort of generate a statement and see the pattern in which data consumption is done. So I have gone through these steps. All these details are there in the POC document, and after going through these steps, I am able to load the database. For example, I loaded a, a purchase list, or a product order of a sales executed in a company, and it has all these data, the information about currency, history of being created, net amount, tax amount, and all that. And you can evaluate all those data on these dashboard. It gives you the various options of arranging the data, the currency, purchase order, and all that. And we can play with that. I mean, we can create a new database, we can create new template, and all of this is running on top of the SAP HANA engine. And this SAP HANA engine is running on top of Red Hat Enterprise Linux. So this is the way. I mean, we can create. I have put some random numbers to this purchase order list, and I am able to see those numbers here. And we can put scripts, SQL scripts, on top of these numbers to play around. So one exercise Hyperscalers does is, on top of these appliances, is engage with the developers, for example, SAP HANA developers, and sort of play with this appliance and come up with the performance numbers. I have executed the same appliance on different environments as well, and SAP HANA is pretty bulky software suite, and the typically it takes about 5 to 6 hours to get the engine up and running. And since we have much better hardware configuration here with 160 gig on each node, and the optimization which Red Hat Enterprise Virtualization platform gives, I was able to get this SAP HANA engine up and running within a couple of hours. So it was pretty good performance experience for getting SAP HANA up and running on Red Hat Enterprise Linux machine. Just little bit walkthrough with this with SAP HANA box. So it has multiple windows which SAP HANA experts would be knowing more about it. For example, there is this cockpit window, and if I log into this, it would give me the way to configure. It will give me a list of all the databases running, all the credentials available, and the way you can manage the users who has access to this web admin, and their security provisions. And there are a lot of templates you can load to this window to manage the SAP HANA configuration. There are plugins available to get SAP HANA fully functional, and you can as well link it to your GitHub. For example, I have created a project in my GitHub repository, and that has been loaded to this project. You can see these JSON files and all. So I can do some CI/CD or some DevOps operations, being since this interface is being integrated with my GitHub login. So all those exercises can be done, and since this appliance is in-house running within Hyperscalers Lab, it gives me a much better performance and flexibility to do these exercises. So yeah, so these were the steps I wanted to show as part of this demo, and I'm happy to help out with any questions or any of these appliances queries. As part of Hyperscalers services, we provide DDNS VPN access to these appliances. You can drop us an email, or you can go to hyperscalers.com and send us a request. We'll be happy to help you out with this demo and any other questions. And this proof of concept white paper should be there online in our website as well. So that's all I had for the demo today, and I'm happy to help you out with designing any of solutions based out of Red Hat Enterprise Virtualization or SAP HANA. Thanks again, and happy to help you again. Thanks.